Hello everybody and welcome back. In this video we are going to be learning about magnitudes and modeling and how we utilize them in physics. Alright, so in this lesson we're going to describe how physicists use models to solve problems and explain phenomena, use ratios to describe relative differences in magnitudes of objects. So modeling is a method used by scientists to approximate objects and situations to make them easier to analyze. It can simplify problems to make them much more solvable, and they are actually just approximations. The more complex the model, the more accurate it is, but also the more detail in the mathematics that you have to account for everything within the model. So we'll usually approximate the shape of, say, like a car to be a box when analyzing its motion. This way we're kind of not accounting for the aerodynamics of the car, we're also ignoring air resistance, so it can be a pretty good approximation. And many times we'll even just reduce the object further to just a dot and watch that dot as we track its motion. We don't actually care about the size or shape of the actual object itself. Alright, so basic models will sometimes ignore parts of the system due to their complexity, and in this class we're going to mostly be ignoring air resistance as an example, due to the more complex nature of the mathematics when you have to actually account for air resistance. Magnitudes are a comparison of two objects. So for example, if someone is jumping twice as far as their competitor, it doesn't tell you exactly how far either person jumped, but it's a relative size difference comparison of each of their jumps. So we can compare sizes that are extremely large if we're having a hard time conceptualizing those actual numbers. For example, with stars and the planets, the sun has a diameter of 865,000 miles, while the Earth's diameter is just under 8,000. It's actually sometimes a lot easier to say that the sun is actually 109 times larger than the Earth. So this picture here gives us a nice kind of size comparison of where the Earth is compared to the sun, and in terms of its size. In this example, we have the sun there. It's a tiny little bead compared to some of the other stars in our night sky, like Arcturus. And Arcturus is even small compared to other stars that we can see, like Betelgeuse and Antares. I call Arcturus is all the way down here. Now, this relationship of ratios in terms of sizes actually is what allows us to get total solar eclipses, because the moon is 1/400th the size of the sun, but it is also 1/400th the distance from the Earth, which means that when it lines up with the sun, that ratio relationship between distance and size allows it to completely block out the sun, and we get those total solar eclipses. Alright, so make sure you check your understanding of some of the definitions and complete the Section 7 concept check.